The next 3 lessons in this chapter are going to talk about ways in which to display data. And today we're going to look at what we like to call a two-way frequency table. So first, two-way frequency table divides the data into categories. And I have it kind of color-coded here, so I'm going to try and stick with that. So we have values that represent the actual information for the table. In this case, as boys and girls, apples and oranges. We would call the values that are related to that, those are our joint frequencies. So how often did a specific thing occur? All right, and in blue you'll see more of our totals. The terminology they like to use as far as defining what type of frequency that is a marginal frequency. So you will make several of these on your own, which we'll practice an example too. But a lot of times when you see two-way frequency tables, we just want to make sure you can read it and analyze what all the data represents. So for example here, in example 1, the table shows the results of students naming their favorite subject. So we have down the row side 2 different people's homerooms. Across the top are their potential favorite subjects when they were asked. So if I wanted to know how many kids in Miss Bailey's homeroom liked math as their favorite, I would know that number is 8. So if I wanted to highlight this, our joint frequencies are the information here related specifically to a homeroom and the subject. Our marginal frequencies are going to be these totals. So between the 2 homerooms, how many kids liked math? How many like science? How many like English? We could also look at the totals of how many people were surveyed in each class. So how many students in Miss Bailey's homeroom prefer math? So if we go her room, math, the value that represents those 2 things is 8. How many students from both homerooms prefer science? That's a marginal frequency, and that would be 13 students. I know it's not a trick, it's very straightforward, so hopefully you find this very refreshing and a nice change of pace. All right, so now let's make a table on our own. This is the part that's a little more time confusing, but it's still not too shabby. So we're going to make a table. First, let's read this problem and determine what our label should be for our rows and our columns. So there are 175 freshmen taking a foreign language. Of these, 88 take Spanish, 44 take French, and the rest take German. No one takes more than one language. There are 42 boys taking Spanish, 31 girls taking French, and a total of 89 girls taking a language. So we definitely have some data here related to languages. So I'm just going to go ahead and highlight those real quick. We have Spanish, French, and German. So we definitely know that those are going to be one of our labels. How else is our data divided up? That would be by boys and by girls. All right, so there's our labels. So for purposes of space, I'm going to go ahead and put boys and girls down as our row labels, just so we have enough room to get everything in here. So we have boys and girls. And then we want to make sure we leave room for our marginal frequencies. Let me go ahead and switch my colors up here. and make sure we have a row for total. So there's our row labels. All right. Now for our column labels. So we have our languages. It doesn't matter which order you go in. I'm just going to go the order they're listed in. So first we have Spanish. Then we have French. German. And again, make sure you leave enough room to do another totals. So you're going to do total both directions. And there's your setup for your table. So now let's start filling in what we know. I'm going to go ahead and erase my first highlights. So we know there's 175 freshmen taking a foreign language. This information is actually the total of the entire table. So we have 175. So that should be the total number of girls and boys, and that should also be the total number of freshmen taking a foreign language. That should be across the bottom. All right, of these, 8 take Spanish. So I'm going to highlight these in red. Now, that does not specify girls or boys. That's just freshmen total. So that is oops, I probably should have highlighted it in blue. That is a marginal frequency. 88 are in Spanish. All right, 46 in French, another marginal frequency, and the rest take German. Now, you could choose to go ahead and calculate as you go, or go ahead and fill in everything you know first, and then calculate as you go. But if you wanted to real quick, we know there's 175 total students. If we subtract 88 and 46 from 175, we would get that there are 41 students taking German. All right. There are 42 boys taking Spanish. So a joint frequency there. We have 31 girls taking French. And a total of 89 girls taking a language. So back to a marginal frequency, 89 girls. All right, so now let's fill the table in. So based on what we know, one of my numbers went missing there. 2 seconds. So based on what we have, we should have enough information to go ahead and fill in the table. You'll never not have enough in everything I assign you. So if we start with this first column, if we know there's a total of 88 and there's 42 boys taking Spanish, that should mean that there are 46 girls taking Spanish. There's 46 total boys total people taking French and 31 girls. That means there's 15 boys taking French. Next, we can determine how many girls are taking German. So there's a total of 89 girls. Minus 46 minus 31 should give us 12 girls taking German, which allows us to figure out how many boys are taking German, which is 29. And last but not least, how many total boys do we have? So 42 plus 15 plus 29 is 86. And you also could have figured out that 86 by just saying, hey, 89 girls, take that out of 175, also 86. Sometimes it's nice, though, to make sure that everything matches up so you can find your own ears. And that's how you create your own two-way frequency table. So last but not least, again, another filled in table trying to determine information based on one. So here we have the number of students living on and off campus, men and women, divvied up by sex and then where they live. So do more students live on campus or off? So sometimes the trick part to figuring these out is which values is it talking about. So it just says students, doesn't specify boy or girl. So we could say on campus total is 7,040, and we have 7,768. So which one of those is greater? That would be the off-campus. So our answer for A should be off. All right, so for B, is it also true that more women live off campus than on? All right, so again, we're doing off versus on, but now we're looking specifically at the females. And it appears that on is actually greater. So that answer would be no. All right,